I'm now recording. Here's the whiteboard. All right, how are we feeling? Everybody ready?
Just like we're at school.
Perfect. Yes, it's true. I use the whiteboard for a study session. So I'll tell you when we get to the calculator portion. So for right now, this is the non-calculator portion. And I'll probably do the same thing tomorrow for the test as when you're on Zoom. Actually, I don't know what I'm going to do with that. I'll think about that. I don't know if I'm just going to be like, put your calculator where I can see it. Figure that out when we get to it. Okay, I'll think about that tonight. So let's say that I just give you, I'm going to give you 3 different integrals that may be solved different ways. There's going to be more, obviously, because this chapter is all about integrals, but I'll just start with 3 different integrals. So let's say I've got e to the 2x. So there's one. See if you can do that one. There's another one. That's a dx. And then Eli has joined the meeting.
Hello, Eli.
Hello.
We just started, Eli. These are our first 3.
All right. Sorry, I was kayaking.
No problem. That sounds enjoyable.
The wind was like right in our faces.
Yeah, actually, I went biking earlier this morning and it was kind of windy, but then I just went on a walk and I was like, praise the Lord, I biked early.
It was so hard.
Yeah.
I was like, sure, I'll have time to make it back. I was paddling full force and it took me like 45 minutes to get back to shore.
That's funny.
Gosh. We're just doing these on our own.
Yeah, and I'll probably only give people like 1 or 2 more minutes just because I told people that since I'm recording, I might give you a little less time in a study session just because then you can always go back and rewatch it if you need to.
All right.
All right. So the main thing is like trying to figure out what type of problem is what on these integrals. I mean, that's the big thing, right? Because there's things that we can actually just go backwards from. We use Q, we use the U and dv thing, we use the shortcut with the U and dv thing. I mean, there's just all sorts of integrals. What do you guys think about number 1?
It's addition, so can you just do the terms separately?
Perfect. Yeah, don't use Q, don't use UDV, just do each one separately. That's perfect. Yeah, so that's kind of what I'm going for on that one, is just kind of recognizing, oh, there's no product rule, nothing. So backwards from e to the 2x is 1/2 e to the 2x. Everybody go with that?
Yeah.
Mm-hmm.
Backwards from sine is negative cosine.
Mm-hmm.
Yeah.
And backwards from x is 1/2 x squared.
Yeah.
And plus c.
Yep.
My hint for you guys is on the non-calculator portion of this test. Literally, like as soon as you just like start your test, whether you're printing it off and then doing it on the test, or whether you're doing it on a sheet of notebook paper, just write plus c at the top of your test so that you remember to put on plus c wherever it is. Like that would be my hint. What do you guys think about number 2? Can we just go backwards? Is it a Q problem or is it a UDV problem?
A Q.
Totally Q, because there's something on the inside, right? Wouldn't you guys use Q as ln x?
Mm-hmm.
Mm-hmm.
Nice. So then dq is what?
1/x.
And then
Nice.
that's the x.
And then I'm just going to multiply by x to get the dx by itself. So then this problem turns into
Q to the fourth.
q to the fourth, nice, over x times x dq, but then the x's go away. So this actually, man, I feel like I've done a lot of them with 1/5. Oh, well, sorry.
Yeah.
Because isn't this 1/5 x to the, or q to the fifth plus
Yeah.
c? So final answer would be 1/5 ln x to the fifth plus c. Everybody feel good about that one?
Yeah.
Sweet. Number 3, I'll probably end up doing on the next page, but what type of problem is it?
It's a chain thing. It's like a
It's the
cross thing.
UDV.
Tabular, whatever.
It's the UDV thing, but with the shortcut. Nice. So even though there's kind of a big thing that goes to zero, yeah, you guys totally got it. So I'll do it on the next page, but it'd be your u's, what was that, 8x squared plus 6x cubed? Is that what that was?
Yeah.
Yeah.
Cool. And then your dv's were the e to the x. Aha, wow. This is fancy. Okay. So then you just keep going forwards, which is what, 16x plus 18x squared? And 16x plus 36x? 16 plus 36x.
Wouldn't it, yeah, I was gonna say, just
What is happening?
Abby was gonna call you out.
36. Call me out, Abby. I'm EVX, EVX, EVX. So this is going to be a long answer, but hopefully it's not that too hard of a problem. Everybody okay with that?
Yeah.
Sweet. So that's plus, this minus, plus, minus. So honestly, how I would probably write my answer is parentheses everywhere, plus 6x cubed e to the x, and then minus 16x plus 18x squared e to the x plus 16 plus 36x e to the x minus 36 e to the x plus c. That's really gross answer. I think Will brought this up, like totally leave it like that if you want. I think he brought up that you could actually pull out the e to the x from everything, and then you'd actually be left with all of the stuff that's in here, and then you could actually do some combining of like terms. So if you wanted to do that, you could. Like you could pull that out, and then I guess your final answer would be, I'm gonna combine all the like terms. 6x cubed minus 10x squared plus 20x, and then minus 20. So I guess you could do that too if you wanted, but I'm okay if you leave it as the blue thing.
I feel like that is a recipe for very small mistakes to happen.
That's true. That is.
It looks a lot nicer though.
That is
Yeah.
true. It does look quite nice. Sweet. I think I'm gonna move on and do a couple more integrals before I do the other thing. Everybody okay so far?
Yeah.
Cool. So here's number 4 and 5, 2 more integrals. So I'm gonna do e to the 2x cosine x dx. And then number 5 is gonna be something with bounds. So watch out for that. Hang on. Yeah, so there's those 2. And then we'll be on to some initial value problems. And for all you guys on here, just so you know, the test is officially at 3. I'll send that out via email, but everybody's good to go. Okay. Sorry, friends. All right, I'm gonna erase this guy. So hopefully with number 4, you guys saw this one coming. Is everybody good with the fact that this is a UDV problem?
Yeah.
Mm-hmm.
So I'm going to go through the start of the work for this one, but this is just one of those that gets ugly, right? You got to do it twice, add it over. Like you just kind of had to know that one of these was coming, essentially. So use e to the 2x, du is 1/2 e to the 2x, dv is cosine x, so backwards is sine, and then that means this equals 1/2 e to the 2x sine x. No. UV. Sorry. Just equals e to the 2x sine x. UV minus the integral of v du. Here's where this comes in. 1/2 e to the 2x sine x. So then what I usually do here is when I'm about to do my next UDV, since I've got a 1/2 to pull out, I'm going to do this sort of thing, right? I'm going to pull out the 1/2 with the minus before I set up my next UDV.
So why is it 1/2 e and not like 2e?
Yeah.
That's me too.
We're taking a derivative.
Oh, my bad. Good call. It's 2. Thank you. This is so funny because this is what happens when I do calculus in the afternoon. And you guys are probably always wishing that we would do calculus in the afternoon because you guys wake up late. But like, my brain shuts off around 3.
Yeah, I recognized it, but I was like, I'm usually wrong 99% of the time in this class. I'm just gonna.
I was too busy working on the 5th problem, so I didn't notice.
That's fair.
It sounds like I'm going crazy.
Oh.
How are we now? Is that better now, everybody? Cool.
These dads.
He is negative cosine there. Okay, I think we're good now. Perfect. Good catch. So yeah, and then you guys double check yourself here. So u v would be negative e to the 2x cosine x, and then minus the integral of v du would be negative 2 e to the 2x cosine x dx. And then we got negatives all over the place. These will make a positive, and then this is going to distribute in and make this one positive, but this one negative. So we're going to have e to the 2x sine x plus 2e to the 2x cosine x, and then minus 4, right? If we pull that other 2,
Or
e to the 2x cosine x. Is that okay for everybody? And then we see that that matches the original, but this time we got to add 4 of these. So a lot of times we're dividing by 2, but in this case, what are we going to divide by?
5.
Yeah. So we're going to have 5 integral e to the 2x cosine x equals this e to the 2 sine x, and then plus 2e 2x cosine x. And then it's going to be all over 5 plus c. We're going to divide by 5. And so this is your final answer. Basically, you just have to know that one of those is coming. How's everybody with that? I would go with Good, unless I hear opposition.
I'm good.
Sweet.
Good.
And then number 5, some of you guys might not have had a chance to look at it if you're still doing work with the other one. Some of you guys might have had a chance to look at it. But go ahead and look at it quick, and if you've tried it or not, any thoughts on what type of problem it is?
Q. Substitution.
Yeah. Q back again. Because Q is 5x cubed. Is that okay for everybody?
Yeah.
Good, because DQ is then 15x squared, and it shows up, which is awesome. So move this guy over here. And then set up your integral. It's 15x squared e to the q, and then you substitute dq over 15x squared. Oh yeah, but this is the one with the bounds. Sorry, everybody, when I miscopied it. It's supposed to be from 0 to 2. So we'll just do the integral first, though. So here we go, and backwards from e to the q is
E to the Q.
E to Q.
q. Plus c, but here's where we actually don't need the plus c, right? I'm going to come over here and I'm just going to say, okay, this is e to the 5x cubed, because that was the q. And then I'm going to say this is from 0 to 2, and this is the non-calculator portion, so we can just leave it unsimplified, right? So what happens if we plug a 2 in?
You get e to the 40 because it's 5 times 8.
Nice. That is huge. I wouldn't want to type that in my calculator anyway, because e to the 40 is ginormous.
Yeah, it's something like 2.4 times 10 to the 17th.
I was going to say, yeah, it's like, and then when you plug in 0, you just get e to the 0, which is,
1.
1.
so this is your final answer on that one. So there's going to be one where you got to plug in the numbers. There was a lot the last test where we had to plug in the numbers. On this test, there's only the one, because we could do with everything, but it just makes it longer. So, okay, we have just a couple more type of problems left before the non-calculator portion. So we're rolling on through. One of them will be something like this. It'll say, solve the initial value problem. And it'll say something like this, right? It'll say dy dx equals, I don't know. Well, I'll make that a squared. Well, no, that's gross. Yeah, I don't want to do that. I want to make it nicer, because the non-calculator part, it's not that ugly, I don't think. Let's do that. And then I'll do something like this. So this is where you guys remember what to do on these?
I think so.
Sweet.
Do I?
Yes.
This is where you go backwards and then you find C.
Oh, yeah, okay.
So it's kind of the same thing, but you got to actually find C this time. And there's kind of 2 like this, but the second one we're going to have to actually sketch on a slope field, so we'll talk about that.
Ooh, there's
Hey, how's that? Good.
Okay, I'll start working on the first one, and then you guys can tell me what's up. So here, technically, we could put the dx over here, but basically you just need to know if you go backwards from dy, it's just y. And backwards from this is x cubed plus 7 over 2 x squared plus c. Then you plug in a 1 into 2, which is gross, but it's not horrible because it's 1 equals 8 plus, and then one of these 2's will cancel. So it's just like 7 times 2, so 14 plus c. So 1 equals 22 plus c minus 22, and you get c equals negative 21. So final answer on this one would actually be y equals x cubed plus 7 over 2x squared minus 21. How do you guys feel about that? Did I do any work wrong?
Good.
Okay.
The next one I don't know how to do.
Yeah, so this
Oh
one,
shoot, I got
Yeah.
Yeah, I forgot how to do this.
yeah, so, and actually, what's nice is I'm gonna give you a slope field, so let me rewrite this one on another page. So it's 2x plus 1, 0, 2. And basically, you're going to get a sketch that I actually just took a picture of on Desmos. And so I'll show you guys like what the slope field will look like, and then you guys will basically tell me where to sketch it in. So the first thing you do, though, is what we just did on the other problem, is you just go backwards, right? So y would equal, what, x squared plus x plus c? Is that okay for everybody?
Mm-hmm.
And this one's really easy, right? Because I want it to be easy when you sketch it. You just put a 2 in here, 0 in, so we get c equals 2. So your answer to the equation is this. Is that okay for everybody?
Yeah.
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 Sweet. And what you need to know, actually, I'm gonna go to Desmos and show you guys what you would see here. So this could be weird, but I'm gonna see what I can do. Okay, coming back to me. So if I go to the slope field, you guys won't have to go to Desmos, okay? So this is on the non-calculator part. But essentially, what I'm going to do, I'm just going to try to show this to you the best that I can here. Oh my. Does everybody remember that day when we did the Chromebook thingy?
Mm-hmm.
Okay, so basically this is like what I did for the test tomorrow is I actually typed whatever equation you guys are going to be finding into Desmos, and then I took like a 5x5 picture and I just cropped it and pasted it right on the test. Because you basically, don't we know that x squared plus x plus 2 is a parabola?
Mm-hmm.
Right?
Yeah.
And technically there you could draw parabolas in here everywhere, right? And so you guys would actually draw in the parabola. I'll go back to like essentially, oh, I lost all my previous work. That's fine. We know it's y equals x squared plus x plus 2. And we know that this thing looks like this all the way around here, right? And after this, it just gets steeper and steeper, right? This is kind of what it looked like here. And on this side, it gets really steep. Sorry that my drawing sucks, but you know, go with it. But basically what you guys are going to do is you guys are going to just draw the one that goes through right around where this one does. Well, here's the easiest way to do this if you guys want to know. You remember how the point was the point 0,2 that we plugged in?
Mm-hmm.
That means that that point is on your parabola. And so you just have to draw in the parabola that would fit in that spot. Is that okay for everybody?
Yeah.
Yeah.
Yeah, basically just find the equation, which you're really good at, and then put that initial point that they give you on the actual slope field, and then just draw it in there. And it'll be a function that you know what it looks like, okay? So even if you're like, all these dashes are on the slope field, like what's going on? It'll be one that you're like, oh, it's obviously a parabola. It's obviously something that you know. Sweet. Here's the last one. on the non-calculator, and it's actually a problem just like one of those, except for one fancy thing. Let me think of what I want to put in here. Yeah, I'll just do this. Plus. So let me do that. So essentially, and then here's an initial point again. Let's do 0, 5. So you guys have to solve this initially again, but anybody know the first step on this one?
Separate the variables, so put
Nice.
2y on the other side and dx on the other.
Yeah, good. So this is the only one where you got to actually separate some variables, but it's doing the same thing. This is the last thing on the non-calculator, and then we are moving in to calculator, which is perfect timing, I think, guys. You guys are doing great. We spent about 30 minutes on the non-calculator, and we'll probably do about the same thing for the calculator.
Should we get our calculator when the calculator portion starts?
Yeah, as soon as you're done with this one, feel free to grab your
All right.
calculator. So backwards from 2y, did you guys get y squared?
Yeah.
Mhm.
And backwards from x plus e to the x, did you guys get 1/2 x squared plus e to the x plus c?
Yep.
Sweet. And then you plug in your 0 and 5, so you get 25 equals 0 plus 1, right? So e to the 0 is 1 plus c. So c equals 24.
Yeah.
Oh,
Sweet. And then your final answer, you can have y squared equals 1/2 x squared plus e to the x plus 24. Or you can square root both sides and you can have y equals square root of 1/2 x squared plus e to the x plus 24. But you do just have to leave it ugly like that. But I would take either one. Boom. Let's do calculator. I do actually see a typo, not a typo, because I'm going to give you guys every formula except for integration by parts, except for UV minus VDU. So I actually need to put the half-life formula in there. Not that half-life is that big of a deal because it's just y equals, the c e to the kt, but when we're talking about decay, that's negative, right? But here we go. So this one, it's going to say something like the decay constant of some element is k equals 1.9. So part A is it wants to know what is the half-life. And part B is going to say how many years until 85% has decayed. So try your hand at those because I'm going to let you guys be the calculator people for this. I'm not going to take them. And I'm going to get my water.
Question
Yeah.
number B, or on part B. Is in the formula, is y the amount left or the amount that's decayed?
It is good. That's a good question. Is the amount left? And that's something that some people did wrong on their quiz. So don't use 85% when you're plugging stuff in. Use the 15%.
Okay, that always confused me.
Yeah. So that's a great question.
There is supposed to be a negative in the half-life formula, right? Like it's a negative K.
Yes, good. So good. So it'll be like 0.5 equals e to the negative 1.9 t.
Okay.
Nice. And then you'll ln both sides, and then you'll divide by negative 1.9. I feel like this is negative 0.69. I feel like I've done that enough that that's what that is, but somebody can quote me if I'm wrong. And then you divide by that. What'd you guys get for t?
I got 0.365.
Cool. Everybody feeling good about that?
Yep.
Mm-hmm.
And then on part B, basically just make sure, I phrased this just so that no one get tricked about it. If it said how many years until 85% is left, then use the 85% there. But if it says till 85% is decayed, always put what's left in your equation. So half-life's nice because if half of it's gone, half of it's still there. You can't mess up half-life. But then here, it's still e to the negative 1.9 t. And then we ln and then divide by 0.19. Negative 1.9. Anybody got that one for me?
1 year.
1 year.
Around.
Oh, right about 1 year.
0.998.
All right.
5.
Nice. I like it. Yeah, I'll go with 1 year. So the next one is a Newton's law of cooling problem. I'm not going to write down the paragraph. I'm just going to give you guys the highlights. But just so you know, I know on the quiz it was weird because it said like how much longer it took or whatever, there's choices. I don't try to trick you or anything. Okay. It just says like how long to cool. So basically it says there's a pi that is I don't know, 375 degrees. Taken from the oven. And then you need to know that the room temperature is, we'll say 70. And then we're going to say after 10 minutes, it's, I don't know, 315 degrees. Find when it will be 100 degrees. And Newton's law of cooling, because I'll give that to you, is T minus Ts equals T naught minus Ts e to the negative k t. All right, I'll start plugging some things in here. Anybody want to tell me what they got for K?
0.022.
Like that?
Yeah.
Sweet.
Yeah.
And then basically, I think everybody's good with these because you guys did some of them in Algebra Pre-Calc, but everybody's good with the fact that you just have to do kind of a second round of this, right? You got to plug 100 in this time for that T. Minus 70 equals 375 minus 70 again. And this time e to the negative 0.00022 T. And then just kind of go from there, right? It'd be 30 equals 305 e to the negative 0.022 T. Divide, and what'd you guys get for T?
116 minutes.
That might not have been super realistic. My bad.
I have got 105.
105.
I don't know. Maybe
That
not.
might be a rounding error, to be honest. Like if you use 0.02 compared to 0.022 compared to 0.022 something. So did you say 105, Joey?
I said I had 114.
I had
Oh.
105.4.
Abby, what did you use for your, did you use 0.022?
Yeah.
Oh. I don't know.
I just used 0.02.
Oh, okay, that's probably it.
Daniel said I had 104 and K equals 0.00 or 0.0223.
Yeah. So I think that's honestly probably just all rounding stuff, to be honest.
Yes.
That can happen. So I'm feeling pretty good about that. Sweet. Yeah, let's move on. This next one is probably the main one that I'm guessing that people needed to see because I did not have one of these on the quiz. It's one of the ones that has the velocity equation. That's supposed to be a parenthesis, my bad. Parenthesis T. So this is a velocity equation, and it's going to say something like there's a 20,000 kilogram truck coasts to a stop from 60 meters per second. And the K that they're going to give you is 160 kilograms per second. And then they're going to ask for two things. Part A is going to ask for how long until the truck's speed is 20 meters per second. And part B, which we might have to do on another page, is how far does it coast before it stops? And part B is the hard part. So I know you guys probably haven't seen this one since we did homework on it maybe, but hopefully this isn't too hard to fill out. What do you guys want to put in where here?
2,000 as the V naught. 20,000.
60.
60 is,
would be the
Oh.
yeah, that's the
Yeah.
original. Yeah. But what is the 20,000? That's kind of weird.
M.
Yeah, that's the max. Nice. So it'll be over 20,000. And the K, they just outright tell us, so that's easy. And then what else do we have to plug in, and what are we looking for?
The V.
Yeah, nice. We have the V. Good. We got 20. And then T. So part A is actually not too terrible. It's almost kind of like a half-life thing once you get everything plugged in there. Is that okay for everybody?
Mhm.
Yeah.
So we're going to divide both sides by 60. And I know that 20 divided by 60 is a third. So that's going to be 0.33. Repeating. Anybody want to take 160 divided by 20,000?
.008.
Nice. And that's something that if we rounded different, we might get something like slightly different, but it'll be fine. And then you guys ln both sides, and then divide both sides by negative 0.008, and then we'll have t. Anybody got that?
Yeah, I got 137.3.
Yeah.
Yep.
2.3 minutes.
Oh, right, that's my bad. Not feet per second. There we go. 2.3 minutes. Nice, I would take either one of those. Beautiful. So the hard part of this one is part B. How long does it coast before it stops? So I'm gonna go ahead and just go to a new page and copy the equation that we had, right? Which is V equals 60 e to the, I'm gonna leave it as negative 0.8 t. Okay, so that we don't have to deal with those ugly fraction. So we want to figure out how far it coasts. But if you notice, doesn't our equation only have to do with velocity?
Mm-hmm.
So how do we get to how far it coasts?
0.
We are going to, hang
5.
on, friend. I lost myself. I'm coming back.
Okay.
Okay, I'm back. Am I back? Everybody good?
Yep.
Sweet. We're actually going to, yes, Daniel's got it. He said antiderivative because the antiderivative of velocity is position. Is that okay? So you get how far it coasts, that's actually position. And then we actually will plug in kind of this initial point, 0, 0, once we take an antiderivative, but we do have to take an antiderivative. So we don't need to separate the variables, they're already separated. Technically there can be a dt on there, but that's fine. So then backwards from velocity is position. And then here's the question though, what's backwards from 60 e to the negative 0.008 t? Well, the 60 can come out front. What's the antiderivative of e to the anything?
It'll be e to that.
But then you gotta divide by the constant.
You know, I think, hang on. Aha, no wonder I couldn't hear you guys. Somehow my knee had turned down the volume. Like, you guys are so quiet. Okay, and then, are you guys good with the fact that we actually have to divide by this though?
Yeah.
Yes.
Okay, and then we're gonna have a plus c. So now essentially what goes on, so just so you know, I mean, this is one of those things that I do have a hard time with since I'm not a physics person. When you're looking for how far it coasts, you really are looking for the c. And they don't give you this, you just have to know you're gonna plug in 0, 0. Because basically it's saying from wherever they started keeping track of things, they're saying that's the starting time and the starting position is 0. And since you're figuring out how far it's gone backwards from that and you've got a negative in your equation, it kind of discounts that. But basically what you need to know is you're just trying to find c. So if you plug in 0, somebody takes 60 divided by negative 0.008 for me.
Negative 7,500.
Yeah.
Nice. And then this is all just 1. So everybody good with, you'd add 7,500 to the other side and that's your c?
Yeah.
So that's actually your final answer for part B. That's probably the one that people have seen the least because we probably only did a grand total of like 3 of those problems. But it leads into the first section of next chapter, which is talking about velocity and acceleration and all those things again. So we needed to see it. Sorry. And then last problem, you probably knew this one was coming. It's going to say you can use this equation, which is the differential equation for logistics. And it's going to say that you can use this equation, which is the regular formula. That is not a z, it's supposed to be an equal sign. like this guy. Oh, that should be a negative. There we go. And then it'll give you this information. It'll be like here. I'm not even gonna make up a scenario. I'm not gonna say this is a population of anything. I'm just gonna be like, solve it. Sorry. As study session has gone on, I have become less creative. 0.0000. And then part A is going to say find K and M.
Is there supposed to be a P in the first term of that?
Yep, thank you. Perfect. My bad.
That makes it make a lot more sense.
That would not make very much sense. Yes.
There's one problem on something we did that was like that too.
Mm-hmm.
Assume that there was a first term.
Yeah, that would be weird. I think that might have been a typo. Was that a typo somewhere else? I think it was. I think it was on the homework. Yeah, the last homework question. And then find in population will reach 120. Boom, this is the last one, peeps. Kept study session to an hour. Might still be a lot for the people who watch the video, but sorry, folks.
Should have came.
Right, that's what-
Down.
If they would have came, they could have gotten Pepsi and crackers. Maybe not.
Well, yeah, you only gave that to me.
Right.
I like how only Abby thought that was.
Daniel said no Pepsi.
So sorry,
Sad
Daniel.
face.
I didn't actually buy anyone anything.
I had a Pepsi right before this, so
I ate cheese during this.
Do you guys know what I found out yesterday, which is super sad? Apparently, the police department does not want anyone to do parades of any sort or like mass drive to anywhere of any sort during this pandemic. So if we do the DQ thing, we're gonna have to keep it under wraps. Granted, there's only gonna be tops 15 of us, 16 plus me, but we gotta keep it under wraps.
We can get trucks, and one person can be in the truck bed, and the other can be driving.
Can't do that either.
Why?
You're not allowed to have someone riding in the truck bed.
They'll lay down.
No.
That's hilarious.
Yeah, I'll be here all day.
Excellent. Thank you, Noah.
great.
Appreciate your.
That's just what we wanted.
Oh.
Okay, you guys will have to double check me, but I mean, K should be 0.03, right?
Yes.
Yep.
And then M, the easiest way for me to get M is to say that if you distributed this, this would be K over M times P squared, but we don't really care about the P squared. We're just setting 0.00003 equal to K, which is 0.03 over that. And so essentially, you just have to take 0.03 divided by 0.00003. What'd you guys get for that?
1,000.
1,000.
Oh, well, that makes sense. Boom. And then I'll probably go to a new slide But remember, this is where you're using the other equation. You plug 20 in here, the 1,000 in here, 1 plus a e to the negative 0.03 times 0. And you guys have been doing pretty good at those. So this would be b continued. 1,000 divided by the 20 equals 1 plus a. Is 1,000 divided by 20 500?
50.
Never mind.
Yeah, it's
50.
50.
And then you minus the 1, so you get a equals 49.
Yeah.
So your final answer to this first part is 1,001 plus 49 e to the negative 0.03 t. That's your final answer to B. And then C, as long as I didn't make up bogus information, hopefully I didn't, is where you put, what was that, 120?
Mm-hmm.
Yeah. You put 120 in here, 1,000, all of this gobbledygook, and then you just solve it, right? But you got to move things to the other side. So you do 1 plus 49 e to the negative 0.03 t equals 1,000 divided by 120. And then you subtract the 1 and divide by 49 and ln and divide. Unless you guys want me to go through that, I'm going to probably trust you. Anybody want to say what they got, and we'll just make sure our answers match?
63.24.
Yep.
Everybody good about that?
Yeah.
Sweet. Let me go up here. Stop recording.